Hello viewers, this is KS New Media. Decided maybe I'll do this little video. I don't know. Decided, earlier today, I'll just do a quick slideshow about how to prove the Pythagorean Theorem. It's a fancy little by KS New Media thing. Let's go. Let's go. Okay. Overview. The Pythagorean theorem was introduced by the Greek philosopher Pythagoras in around the 3rd to 4th century AD. I don't know the exact date. This is what I learned in elementary school. But commonly used formula to find the length of the hypotenuse of a right triangle. It implies that the squares of the legs of the triangle, which would be A, let's spell my pen. Hold on a minute, guys. Just pardon me for a moment. Alright, guys, we're back. Well, as I was saying, so the Pythagorean theorem implies that the squares of the legs, this is leg 1, leg 2, my terrible circle, behold, are equal to the hypotenuse squared. This is the hypotenuse. This is the whole thing. But these are actually the sides of the triangle. You wouldn't write a normal, you won't write side of a regular polygon as squared. Okay, let's go to the next slide. In color. I want it. Maybe I'll go. Let's go black. Okay. Diagram for visualization. As I said in the previous slide, note that the sides themselves are not squared. You wouldn't normally write the sides of a figure to have exponents. That doesn't make any sense. So here you see my terrible line. So here you see the hypotenuse is opposite the right angle. So in order for this to be a right triangle in the first place, it has to be opposite. It has to be opposite the right angle that is formed by the two legs of the triangle. Okay, the legs are not the same thing as the hypotenuse. The hypotenuse of a right triangle it's longer than both of these. A plus B. Well, rather, A squared plus B squared equals C squared. So that means this hypotenuse is longest. Okay, let's go to the next side. If it's gonna work. Okay. So I want to demonstrate just the most detailed way I know. It's the one I learned. So let's see. First a picture. So I want to break this down for you. If you have to write a formal proof or whatever, you should draw a square. Yeah, a square. A terrible square that looks nothing like this one. Don't forget to use a ruler. Then to draw the square on the inside, just turn the page diagonally. Make tick marks at the middle of the large square on each of its sides. The middle of each of its sides. The midpoint of each of its sides, which in this case are A, B. Then you can draw the square from one point to another point, to another point, to another point. Okay, and since these triangles are all congruent, and A and B are congruent, so you could call this whole side 2A or 2B. Depends on the way you want to reference to it. Okay. As you saw, there were 4 congruent triangles depicted, as well as an inner black square and an outer blue square. The colors are just for differentiation. If we calculate the inner square's area, we get the result C squared. This is because hypotenuse C it's shared with the black square, and the square's area is length times width. It's kind of reminiscent of proving triangles congruent using the reflexive property. Similar concept, but not exactly the same. Then you see that the expression, like AB equals the length of one side of the outer square, because that is the length. We'll go back to the other side. This whole length is one side, and B plus A, or A plus B, therefore equals the length of one side of the large triangle. Long square. Large square. I'm sorry, I can't speak. Morning sickness. So the area, therefore, is AB squared, as the area of a square is S squared. So we're going to say that the small square plus the four triangles equals the area of the big square, so it's all balanced out. So let's simplify the triangles first, just follow the step. Now we can write the full equation as A plus B, in parentheses, squared equals C squared plus 2AB. Next. So let's clean it up, simplify. So start here, you just square, distribute, and since you have two A's and two B's, you're going to have to root 2AB. This itself is the coefficient of these, A, B. So it's basically 2 times A times B. Plus B squared, as we distributed this. Let me use a different pen. In color. So the exponent gets distributed by the distributive property. And C plus 2AB is as is. So we can subtract 2AB. Sorry, my handwriting is terrible. AB. Subtract 2AB from both sides, and voila, you got A squared plus B squared equals C squared. So that, in essence, is how you prove the Pythagorean theorem. So you can show this off to your friends or whatever. So let's go quick recap. So draw large square, measure the midpoints of the sides of the large square, and draw a smaller inner diamond, rhombus, whatever, whose points meet at the midpoint of each of the large square sides. Then you label everything, and don't forget to label the right triangle. You'll need this area in a formal proof. And label the inside of these large squares. The small square, sorry. So for congruent triangles, and since the area of a triangle is half base times height, AB, since they're the legs, A could be the height, B could be the height. It's used interchangeably. So when you multiply that, you simplify, and since AB really is AB over 1, when you multiply that, that's 4AB divided by 2 in parentheses. And when you distribute everything, when you multiply the whole thing by 4, you get 2AB. So you combine everything, and you write the equation as follows. And yeah, my terrible writing. Simplify this, as I explained before. And yes, for the most part, that's it, guys. That's how you prove the Pythagorean theorem. If you like these kind of quick tutorials, like, comment, subscribe, and stay tuned for more. See ya.